Hello guys, welcome to my YouTube channel. I am Hashir Khan SJ, pursuing my second year of engineering in CSE Cybersecurity branch from Sri Venkateswara College of Engineering, Bangalore. Guys, today's topic is realization of Boolean expression using NAND and NOR gates. Guys, now let us see introduction to Boolean expressions. Boolean expressions are a fundamental concept in digital logic and are used to represent and manipulate logic relationships. They are built using logic operators such as AND, OR, NOT, XNOR, NAND, and NOR. Boolean expressions are expressed in terms of variables that can take on two possible values, true 1 or false 0. These expressions form the foundation for designing and implementing digital circuits. Guys, now let us see fundamentals of NAND and NOR gates. NAND and NOR gates are considered universal gates, meaning that they can be used to construct any other logic gates. The NAND gate is defined by its output being true only when all inputs are false. The NOR gate, on the other hand, output true only when all inputs are false. These fundamental properties makes them valuable building blocks for complex digital systems. NAND gate has a true output only when all inputs are false. This means that if any input is true, then the output will be false. It is essential that opposite of an AND gate. Hence the name is not AND. NOR gate. NOR gate is a logic navigation of OR gate. It has a true output only when all inputs are false. If any input is true, then output becomes false. It acts like an OR gate followed by inverter. Guys, now let us see properties of NAND and NOR gates. Both NAND and NOR gates exhibit specific properties that make them crucial in digital circuit designing. Are making NAND gates idempotent, meaning the output is same regardless of the number of times the input is used. NOR gate also possesses this property. Additionally, NAND gate are associative, meaning that the output remains unchanged even if the order of input is altered. NOR gate as follows the same rule. NAND gate properties: idempotent, associative, cumulative, distributive over OR. De Morgan law applies. NOR gate properties: idempotent, associative, commu- commutative, distributive over AND. De Morgan's law applies. Guys, now let us see realization of basic logic gates using NAND and NOR. Since NAND and NOR gates are considered universal gates, they can be used to realize other fundamental logic gates like AND or NOT and XOR. This realization is achieved by considering combining NAND or NOR gates in specific configuration to mimic the desired function. The ability to construct complex logic circuits from a limited set of universal gates simplifies the design process and reduces the number of components required. Gates: AND gate, NAND implementation, two NAND gates in series. NOR implementation, two NOR gates in parallel. Gates: OR gate, two NAND gates in parallel, two NOR gates in series. NOT gate, a single NAND gate with both input connected. NOR gate, a single NOR gate with both input connected. Guys, now let us see realization of logical OR using NAND and NOR. The implementation of logical OR gate using NAND and NAND gate involves connecting two NAND gates in parallel. The output of both NAND gates are then connected together to form output of OR gate. These inputs are fed to respective input of the NAND gates. To realize an OR gate using NOR gates, we connect two NOR gates in series. The output of first NOR gate is connected to the input of second NOR gate. The input are fed into first NOR gate and the output of the second NOR gate is represented the output of the OR gate. First one, NAND gate implementation. Two NAND gates are connected in parallel with their output connected to form a OR gate output. The inputs are fed directly to the NAND gates resulting in OR function. NOR implementation. Two NOR gates are connected in series with output of first NOR gate feeding into the input of second NOR gate. The input are fed to the first NOR gate and the final output comes from the second or NOR gate. Guys, now let us see realization of logical NOT using NAND and NOR. A logic NOT gate is easy realized using either NAND or NOR gates. For a NAND gate implementation, we connect both input of a single NAND gate together. This configuration effectively inverts the input signals, representing the NOT function. Similarly, for a NOR gate implementation, we connect both inputs of a single NOR gate together. This argument inverts the input, achieving the NOT function. This simplicity highlights the universality of NAND and NOR gate. NAND gate implementation. A single NAND gate is used. Both inputs of NAND gates are connected together. The input is fed into the connected input and the output is inverted signal. NOR gate, NOR implementation. A single NOR gate is used. Both inputs of NOR gates are connected together. The input is fed to connected input and the output is inverted signal. Guys, now let us see realization of logic XOR using NAND and NOR. The implementation of logic XOR gate using NAND and NOR gates requires a slightly more complex arrangement than the previous gate. Using NAND, we need four NAND gates to connect in a specific configuration. The first two NAND gates acts as NOT gates by connecting their inputs together. The output of NOT gate feed into the third NAND gate which acts as an AND gate. The final output of XOR gate is then obtained from the fourth NAND gate, which receives the input from the output of the third NAND gate and original input. NOR implementation of XOR follows a similar pattern but uses NOR gates instead of NAND gates. Step 1. NAND implementation. Two NAND gates acts as a NOT gate by connecting their inputs together. NOR implementation. Two NOR gates acts as a NOT gate by connecting their inputs together. Step 2. NAND gate implementation. The output of NOT gate feeds into the third NAND gates. NOR gate implementation. The output of NOT gate feed into the third NOR gate. The third step, NAND implementation. Fourth NAND gate receives the input from output of third NAND gate and the original input. NOR implementation. The fourth NOR gate receives the input from the output of third NOR gate and original input. Guys, now let us see advantages and disadvantages of NAND and NOR realization. The use of NAND and NOR gates for realizing other logic gates represents several advantages. It simplifies the design process, requiring fewer unique components and potentially reduce the overall cost of digital system. Additionally, using a universal set of gates can facilitate the manufacturing process and allow easier integration of various components. However, there are also disadvantages. NAND and NOR gate implementation might result in more complex circuit layout with increased wiring, potentially leading to a large physical footprint and potentially impact performance. Advantage: simplifies design reduces component count, facilitates manufacturing, and allows for easier integration. Disadvantages can result in complex circuit layout with increased wiring, leading to a large footprint and potential performance impact. Guys, now let us see conclusion and applications. The use of NAND and NOR gates as universal gates offers significant advantages in digital circuit designing, simplifying the implementation of complex logic functions. This simplification leads to a more streamlined design process and reduces component count, ultimately contributing to more efficient and cost-effective digital systems. These universal gates are crucial in varieties of application, ranging from basic logic circuits to sophisticated digital systems, including microprocessor, memory controller, and complex control systems. The versatility makes them indispensable in the modern world of electronics. Digital circuits, NAND and NOR, are fundamental build blocks for varieties types of digital circuits, including combinational and sequential circuits. Microprocessor, they play a vital role in construction of microprocessor, where the complex logic operations are performed at a rapid pace. Memory controller, NAND and NOR gates are essential in memory control designing, mapping the flow of data to and from memory units. Control systems, they are utilized in complex control system, implementing logic functions to regulate and manage various processes. Guys, thank you for watching this video. Please do like, share, subscribe.